Okay, now let's move on to terms, which are the things that end up being indexed in an information retrieval system. And what I want to stress is how these can differ from what was the actual input words in the document. Let's start off with a very simple example of that. A common traditional technique in information retrieval systems is to have stop words which go together to form a stop list. So the stop list is precisely words that you exclude from your dictionary. And those words are the words that are the commonest words of a language. So for English, words like the, and, to, and things like that. And the traditional reasons for doing that is that stop words are extremely common. So there's this rule of 30 that the 30 commonest words in the language will account for about 30% of all the tokens that you're indexing. But at the same time, on first glance, it seems that stop words have little semantic content, that you don't really need to index the and to get at the topics of what documents are about. And so therefore, one of the ways in which the set of terms would differ is that the terms would simply just not include these words. However, I should note that the general recent trend has been away from having stop words and leaving some words out of the index. And there are several reasons for that, which all come together to mean that modern systems nearly always index all words. And those are, we've worked out good ways to compress what goes into an index so that these compression methods are sensitive to the commonness of words. And so therefore it actually costs you very little to index stop words. It doesn't comprise 30% of your indexing space. Similarly, we've come up with good query optimization techniques, so it doesn't cost you very much at query time to include stop words. And finally, it's been clearly seen that they're actually very important for certain kinds of queries. So if you're going to do a query on a complete phrase like King of Denmark and want to match that phrase, well, that's hard to do if you're not indexing the of. There are various poems and song titles, here are a couple of examples, Let It Be, To Be or Not to Be, which are comprised purely of stop words, but they're the kind of things that users look up and you'd like them to be able to find them. Stop words also turn out to be important in relational queries. So if you want to be able to be looking for flights to London as opposed to flights from London, you have to be indexing those stop words. Well, that was stop words, but there are other ways in which we might want to normalize the words that we find in a text and to create terms that differ from them. Here's one example. So you can write USA with periods after each letter or leaving them out, and yet we'd like to treat those as the same in the sense that if a user entered one and the document contained the other, we'd like them to match. And the easiest way to achieve that is to do a form of normalization which makes these the same, such as turning this one into USA. And so that's then more clearly our notion of a term. So a term is a normalized word type which is an entry in our information retrieval system dictionary, and it may differ from the actual tokens that appear in a text by having applied various kinds of normalization rules. So the most common way to do this is to implicitly define equivalence classes of terms by writing normalization rules. So for example, I just mentioned that one already. So if we have a normalization rule that deletes periods that are adjacent to alphabetical letters, well then instances of u.s.a in a document will be mapped onto just USA, and so these two things will fall together. So we've created an equivalence class of two surface forms by means of writing a rule. And there are similar ways that you can handle other cases. So if you just delete hyphens in the middle of the words, then these two surface forms will fall together to be indexed as this single term. Again, this is an issue where there's variation depending upon the language. So for many languages, such as say French, you'll have accents, and you might want to have words become the same term regardless of whether they're written with or without accents. slightly more complex issues in German, where you have these umlauted letters for which there are standardized ways of writing them in terms of just basic letters by putting a following E. And again, we'd like to treat those equivalently. And in particular, for a lot of these issues, the issues aren't ones of formal linguistic correctness according to grammar rules or style guides. The real issue is, how are your users likely to write these queries? And what you find in a lot of cases is, for reasons of either difficult to use software or laziness, that users are just going to write the basic letters and leave out all the accents and complications. And so that's often the way we want our search engines to work. And so, for example, like this Tübingen example, well, formally, both of these two are correct and equivalent, and this is a different word. But maybe users are going to enter that one anyway, when actually they're meaning one of these two things. So we may well actually want to normalize all three of these words so that all three of them just get indexed under this form. The issue of word normalization brings back some of the issues we looked at previously for doing tokenization in different languages. So we talked about ways of having date tokens, but one part of that issue is you can write the same date in different ways, and we might want to normalize them so they get treated as the same term. Or we saw that with Japanese, you could write a word using either Chinese characters or with the syllabic kana characters. And again, you might not want to normalize them to treat them as the same form. And so what we see is that normalization as well as tokenization is dependent on the language, and so you need to be doing language detection to be able to make the correct decisions of then doing term normalization. But beyond those issues, let me just focus on one more issue which isn't so dependent on the language, is that having this process of matching between terms work depends on doing completely identical normalization of both the index text and the query terms. If you normalize one way the document and another way the query terms, well then you're certain to have things not matching that should have matched. So you want both of those to be identical, which means if you have language particular normalization of the documents, then you also have to be working out how to do the same kind of language particular normalization of the query terms. Here's another form of normalization, which is getting rid of case distinctions. So commonly we index everything lowercase, and that's a fairly practical thing to do. Of course, there are problems with this. Here are some of the problems. So General Motors as a company, you want to treat differently to the words general and motors. SAIL is the Stanford Artificial Intelligence Laboratory. You'd like to treat differently from SAIL for sailing yachts. There is some information conveyed by capitalization. However, despite that, what you commonly find is that search engine users will just write everything in lowercase, or very occasionally everything in uppercase, regardless. And so it's much easier to match query forms to document forms by turning everything into lowercase. But, you know, again, it can cause some problems. Here's one more example of that. Now, this is actually an example that has gone away. One of the problems with teaching these information retrieval classes is every time I have an example of something that Google does wrong, well, you know, their engineers watch these classes and they go off and fix things and the example goes away. And so this particular example is no longer true. It was fixed in 2011. But for many, many years, if you put into Google the query c.a.t., which you're hoping to have match Caterpillar Inc., who produces those sort of big yellow tractors and things like that. What you actually got was that the top matches were for cats. Well, actually in recent years the very top match was for lolcats, but it definitely wasn't for Caterpillar Inc. And so very clearly what was happening there was that there was being this kind of period deletion that we motivated for USA, and then there was being lower casing of queries, and so you got cat there, and that was what what was being matched on. But clearly, if the user had actually taken the time to put as their query c.a.t., then they've given you a lot of information, and it's much more useful if they can be taken to the Caterpillar Inc. homepage. And so that suggests that there are better things that you can do than this simple kind of equivalence classing normalization that we've just been talking about. And here's one more example of this. So if you consider a user entering queries, so if they enter window, well, it'd be useful to match documents that have window and Windows in them, but they're probably not talking about Microsoft Windows operating system. If they type in Windows, well, they might be talking about regular glass windows, and so you might want to match that in the singular or plural, but they could easily also be talking about Microsoft Windows and just didn't bother to type the capital W. In the final case, if the user has typed the capital W Windows, then almost certainly they might want the Microsoft operating system. And so this suggests that rather than just equivalence classing all of these forms together, as we talked about previously, you might want to keep them separate and instead do selective query expansion. And in general, that is a more powerful technique, but it costs you more. It makes the search lookup more costly than it would be if you equivalence class them together. If you go on this direction, there are a lot of other issues you get into, because maybe you shouldn't only equivalence together car and cars, but maybe you should also index together car and automobile synonyms. You might want to deal with language variants like British English or American English. And in general, there are two ways you can do this. You can either, at indexing time, form these equivalence classes. So car and automobile both get formed into this equivalence class of car automobile. Sorry, it line braked there in PowerPoint. And so they're just indexed in one place, and looking up either finds documents that contains either word. Or the other alternative is we can do query expansion at query time. So we have separate postings lists for automobile and car, but when someone searches for one of these words, we get the postings list for both. And so effectively we're expanding their query into a query of car or automobile. Okay, and there are other issues which we'll talk about more later. So what about spelling mistakes? You can think of those as forms that you'd want to put into the equivalence class with words with the proper spelling. But normally spelling is treated separately, and we'll discuss how to do that in another segment. Okay, that's told you quite a bit about some of the things we do to equivalence class to make terms from the original tokens. There are a couple of more cases that we'll talk about separately in the next segment.